Hi everyone, I'm Dr. Z, and today I'm going to talk to you about light. Now, you've already learned some stuff about light, and the information that I'm going to present here to you is a lot of information. But the cool thing is, you can rewatch this video if you want, or more importantly, is that you can be an observer and use things that you find around your house to make observations about what we're talking about, and you can be a scientist. So, let's talk about light. Light is a type of electromagnetic radiation, and it travels in waves, like this. Now, electromagnetic radiation means that it has both an electricity component to it and a magnetic component to it. But the waves are actually so small that you can't really see them. It looks as though, when we observe light, that it's traveling in a straight line. Now, there are also different types of electromagnetic radiation, including microwaves, what you use to heat up your food, ultraviolet rays, which is the reason why you wear sunscreen, so that the sun doesn't burn your skin. But all of these different types of radiation travel as waves that are so small that you can't see them. It also travels extremely fast. So the speed of light is 670 million miles per hour. This comes down to 186,000 miles every second. So light travels so fast that in 1 second, it can go crisscross from California to New York across the United States 70 times. 70 times in 1 second. That's really fast. Now, because we observe light traveling in a straight line, whenever the light hits an opaque object, it's reflected. Now remember, opaque means something that light can't travel through. It's solid, so like a block of wood. Or in the case that I'll be talking about today, a mirror. So the difference between a block of wood and a mirror is that the mirror is shiny and the block of wood is not. So whenever light hits an opaque substance, it is reflected. But if the object is more shiny than dull, it'll actually be reflected better. So in the case of mirrors, mirrors are very shiny substances that are going to reflect the light. And we can have different types of mirrors. There can be a flat mirror, which is the mirror that you're used to seeing in, say, your bathroom. Or there can be curved mirrors. There are two types of curved mirrors, an incurved mirror and an outcurved mirror. We call the incurved mirror concave because it caves in. And then we call the outcurved mirror convex. And all of these different mirrors are going to reflect light, but they're going to reflect it in a different way. Because if I have a wave of light coming into a flat mirror and it hits it straight on like this, so at a 90-degree angle, I don't know if y'all talked about angles yet, it's going to reflect straight back out like that in a straight line. But if it hits it at an angle, say it's coming in from the top like this, the light comes in, and when it hits the mirror at this angle, it's going to reflect back at a different angle, going outward like that. Now, what happens whenever the light hits the concave mirror at an angle? So when it hits the concave mirror, it's going to see this little tiny bit of the surface, even though it's concaved, it's curved, it's going to see this little bit of surface kind of as a straight-ish portion, so it's also going to reflect the light like that. So it depends on the angle that it gets reflected at. If it hits it at a very large angle, then it'll have a very large reflection. So if I have light that's coming in at an angle like this, what we call a shallow angle, it's going to be reflected at a shallow angle. So it just depends upon how and where the light hits the surface of the mirror. For a concave mirror, it's going to hit it like that and bounce away. When it hits a convex mirror, it will hit the surface and be reflected, also at different angles. So it just depends on how and where the light hits the different mirrors. So we have 3 different types of mirrors: flat, concave, and convex. And concave and convex are both curved. One's curved in and one's curved out. And the cool thing is there are different types of concave and convex mirrors as far as how much curvature it has. So you can have one that looks not very curved, but you can still see that it's not flat, right? And then you can have really curved mirrors where it's very obvious that it's curved. And the same thing is true of the convex. So you can have many different types of mirrors. Now, as you know, mirrors produce images. There are 2 types of images that we can see in a mirror. One will be upright, and the other is actually inverted. And so the upright image, which is the image that we're used to seeing in, say, the bathroom mirror, is called a virtual image. This is actually because this upright image seems like it's going to be produced behind the mirror, but of course a mirror is opaque, so images can't move behind the mirror, so it appears to be upright. Then we have inverted, which means flipped. So actually, instead of looking at yourself in the mirror where you look right side up, you're going to look upside down. And this inverted image is called a real image. Now, the concave and convex mirrors can produce upright or inverted images, but the flat mirror will always produce an upright image, right? You've never looked into a flat mirror and noticed that you look upside down. Instead, if you want to look upside down, I suggest that you actually look into a concave mirror, because the concave mirrors are what's going to produce the inverted image. The convex mirrors and the flat mirrors will produce upright images. So upright are produced by the flat mirrors and the convex, so curving out like that. Now that we've talked about how light behaves whenever it hits an opaque object, let's talk about what happens whenever it hits a translucent object. Now, a translucent object is one that allows light to actually pass through. And the most typical type of translucent object that we think of whenever we're talking about light passing through is a lens. And lenses are used in glasses. So if you wear glasses, you have lenses, in microscopes, in cameras, in all sorts of things. So how does light behave whenever it passes through a translucent object? Well, it does 2 things. It can also be reflected. So light is reflected whenever it hits a translucent object, and some of it is refracted. So, what does refracted mean? Well, it's the opposite of reflected. So, refracted is the opposite of reflected, so it means it passes through. Now, this means even though light travels in a straight line, whenever it hits a different material, in this case the translucent material, it still looks like it's traveling through a straight line, but it turns out it's bent whenever it gets through. So say we have a lens that's made of glass, and we have some light and we pass the light through the glass. Some of the light will be reflected, but most of it will pass through the glass, and it still looks like it's traveling in a straight line, which it is, but whenever the light hits the glass, it'll travel through the glass, still in a straight line, but look at how it bends it a little bit. So we're going to talk about different types of lenses. We can have a flat lens, just like we did with the mirrors. We can have a converging lens, which looks like this, and we can have a diverging lens, which looks like that. Does that look familiar? A converging lens kind of looks like two convex mirrors put together, and the diverging lens looks like two concave mirrors put together. So a converging lens is whenever the middle is thicker than the ends. A diverging lens is the opposite. A diverging lens means that the middle is thinner than the two sides. Now, if you have glasses, you can actually take them off and flip them and look at the lenses and see whether you can tell that your lenses are converging or diverging. So if you take your glasses and you look at them in this way, you can kind of see whether or not the lens converges or diverges. In this case, my lens looks like it's swooping down like that, right? So it's a diverging lens. I have examples right here in real life. So this is an example of a converging lens. You can see the middle is thicker than the two ends. And this is a diverging lens. The middle is thinner than the two ends. And they're both gonna bend light in different ways. And so, if you can take a light source and shine it through the lenses, you can see the different ways that the light bends. So in the case of the diverging lens, if I shine a green light here, it looks like it's going straight through, right? But as soon as I start moving it up to the place where it's curving more on the top, you note that the beam actually bends more. So notice how it bends up like that whenever I move it up to the top. It looks pretty straight when it's in the middle, and then when I move it down like this, it bends down. So at the top, it bends it up and moves it away. In other words, it diverges. It gets further and further away at either ends. The converging lens actually does the opposite. When I shine the green light in the middle, it looks like it's coming out straight through like that. But whenever I move it up to the top, it's actually going to bend it closer. And whenever I move it to the bottom, it's going to bend it closer up like that. It converges. They move together. That's what converging and diverging mean. This is kind of how a prism works. Whenever white light passes through a prism, it actually breaks up the light into its different colors. So white light is composed of all the different colors. So if I have a prism and I shine a white light on it, and as soon as it hits that glass or plastic, it will actually start bending the light. But it bends the different colors at different rates. So the red light bends least, and the purple light bends the most. And so this white light gets broken up into all these different colors. Now the main reason we use lenses is to magnify things. And magnify means change the size of. So we can either make objects appear bigger or smaller. And actually, convex and concave mirrors also magnify things. So we use mirrors and lenses in things like microscopes and telescopes. So the way that a telescope works is it takes two converging lenses like this. And say I'm looking at a faraway star. It brings the light from the star and actually focuses it using the two mirrors. So it passes through the first converging mirror. And then say, I don't have two with me, but say there's another converging mirror here, and it focuses that light to where you can actually see it. So if this is your eye, the telescope focuses the light from the star so that you can see it. You can also look at the moon, which doesn't produce its own light, but instead reflects the light from the sun. This is very similar to how a microscope also works. A microscope uses two converging lenses and a light source. So whenever you put the object that you want to see through the microscope at the other end of the lenses, you also need a light source. So the light travels through the two lenses, and in this case, instead of making the object look about the same size in the telescope, or it can magnify it, it just depends on how you have the focus, the microscope actually magnifies this very small object. So if light rays come in through the two converging lenses, whenever the light rays pass out of both of the lenses, the object looks a lot larger. And so that's how telescopes and microscopes work. They not only use two lenses, but they can use more than two if they want, or they can also use mirrors. It just depends on the type of equipment. Now that I've explained how mirrors and lenses work, it's time for you to go exploring to see what you can find around the house. There are many different types of lenses and mirrors that you can find in everyday objects, such as mixing bowls. If you have a metal mixing bowl like this, sometimes you can look inside of it and notice it acts as a concave mirror. So you can see how the images behave in the mixing bowl. Or my favorite are spoons. Small spoons work too, but if you have a large spoon like this, you can flip it up to this side where it looks like a concave mirror, and you can look at yourself in it. Then you can flip it around and it looks like a convex mirror, and you notice how your image changes as you change the distance closer to your face and further from your face. Those are everyday mirrors. You can also look at the flat mirrors that you have in, say, your bedroom or your bathroom, or one really good example of a concave mirror are on cars. Rear view mirrors are concave, but their curvature is not very apparent. But you can notice that in this concave mirror, your image actually looks way bigger than yourself. And lastly, with lenses, you can use your glasses, or you can use something like an empty plastic soda bottle filled with water, or something like a round vase like this with water. And when it's filled with water, it acts like a lens. So you can look at different things through the lens and see how things change. So now it's your turn to go and explore the lenses and mirrors around your house and see what observations you can make and how different lenses and mirrors affect the images. Do they magnify it? Does it make it bigger? Does it make it smaller? Does it invert it? Does it flip it upside down? I don't know. You should go out and explore for yourself. Thanks, everyone.